It's like I keep wanting yeah.
Anybody wants to give quiz 6? If you've done quiz 6, can you give it to me, please? Anyone else would like to ask quiz 6? Anybody wants to handle quiz 6? Oh, you done? Oh, thank you very much. Yeah. How is it? How was Sri Lanka? You had a good time in London? Oh yeah.
Yeah, I don't know. I'm not having it. I was like sure this one in the question 10.
It's M, yeah. It's M.
Oh.
Not N, M.
It's
M, M for mother. Yeah. Alright guys, let's see. Had you done question 10 guys? It should be easy guys because I mean it should be easy for you because quiz 5 you already done quiz 5. So you have p hat equal to you have p hat equal to x bar plus 1 divided by n plus 2, right? And we want to find the bias of p hat, which is the expectation of p hat minus p. I'm sure all of you know that, right? So this is the expectation of x bar plus 1 divided by n plus 2 minus p. Yes? Now take the expectation inside, you get 1 over n plus 2 yes? Yeah. All right. Now I'm gonna ask you something now. What's the expectation of xi? Come on, guys. What's the expectation of xi? For a binomial distribution, what's the expectation? Talk to me, guys, please. What is m times p, right? M times p. Yeah. Okay. So what you get is 1 over n plus 2, and this guy here reduces to mp plus 1 minus p, and this is clearly not equal to 0, right? All right. Hence, the conclusion is that p hat is a biased estimator. All right. And for it to be unbiased, for an unbiased estimator, the bias must be equal to 0, which is not the case here, right? So that's the first part. The second part of the question is to find the variance. This is coming to your quiz number 6. So this is the variance of this, yeah. Now this you can write as the variance of x bar divided by n plus 2 plus 1 over n plus 2, right? Now, what do you know about the variance? You see, this is a constant. So if you add or subtract a constant, doesn't make a change to the variance. So this is the same as you know this, right? Because a constant doesn't change the variance. Adding or subtracting a constant doesn't change anything. Doesn't change the variance. But when you take the n plus 2 outside, you have to square it, right? All right. Okay. Now the next thing. Running out of paper. Just a minute. Let me get some paper. Now I'm going to take the variance inside the brackets. So when you take the variance inside, this is what you get, right? Now I'm sure all of you know the variance of a binomial, which is m p times 1 minus p, right? So this is the variance of a binomial. So the final answer is n plus 2 squared n which approaches 0. Alright, so that's question 10. Alright, so can you do question 9 please now? Question 9. Question 9 please. Are you guys okay with this? Any questions you have? Anybody hasn't signed estimate sheet? Or yes, something is Alright guys, shh. Listen guys. So we want theta hat to be unbiased, right? So it means we want the bias of theta hat to be equal to 0. Okay? Okay? Now, for the uniform variable 0 to theta, the expectation, I'm sure all of you know, is theta by 2. Okay? Okay, so this will be k over n times n theta by 2 minus theta. And this is 0 if and only if k is equal to 2. So the answer is k is 2, right? Sure, all of you got that right. Assume. Right, so that's the first part. The second part of the question is to find the variance. So the variance of theta hat is going to be the variance of 2 times x bar, right? Pull the 2 outside, you get 4 times the variance of yes. Take the variance inside, you get 4 times divided by n squared times the sum of the variance of xi. And I'm sure you guys have good memory. The variance of a uniform variable is b minus a squared divided by 12, right? So which in this case will be theta squared divided by 12. Yes? Okay? So this is 4n squared times n theta squared divided by 12, which is theta squared divided by 3 and 3. Alright. Can you do question 8 please now? 8. You guys just come turning up. No. You're doing question eight. Yes, sorry.
Do you ever step in? Like this.
Yeah.
I'm going to sub that in for minus 6.
Why is it mine? Because
Because I know that that's equal to 0.
no, you got it the other way around. Sorry, can I have your pen?
I've done one around.
Yeah.
Oh,
It should be that variance is equal to the expectation x squared minus the expectation squared like this.
Yeah, right.
Yeah. So this is 0. So because this is 0, this is the same as sigma squared. Yeah. We are doing question 8, guys. Now it's getting late. You can do it this way, sir. You can try to do it this way. Find the question. Right. I think some of you are kind of stuck, but let me show you. There are, you can do this question in 2 or 3 different ways, but the shortest one is the one I'm going to show you. How to do it short and neat. So this is question 8. Right, this is what you have. Okay, we need to find the k so that the bias is 0. So the bias right, this is the bias. Okay, can you guys listen, please? Right, now this you can write as k Right? You see what I've done? Are you listening to me or what? I have multiplied by sigma squared and divided by sigma squared. Now let me check your memory. What do you know about this expression here? We did this while ago, about 2 or 3 weeks ago. What distribution does this have? Huh? Come on, guys. Talk to me. Do you revise your notes or what? I gave you in the notes. It's in the scan notes somewhere. I gave it to you. What distribution does it have? No idea. Oh, come on, guys. That means you don't read your notes. It has a cascade distribution with n degree of freedom. It's in the scan notes. It's in the notes I gave you. Right? Anything of this like this has a cascade with n degree of freedom. Right? And one property of a cascade with n degree is that the expected value is equal to n. The expectation of a cascade variable is equal to the degree of freedom, and this is 0 if k equals to 1 over n. So the answer is k is equal to 1 over n. Alright? And the second part is trivial, because if k is 1 over n, you have this as the estimator. Right? And this you can write as this, right? Again, multiplying and dividing by the same number. And this is for the same reason I just mentioned, right? This is a cascade variable with n degree of freedom. So this is the sampling distribution. So this is the sampling distribution of the estimate. All right. Any questions? Is that okay, guys? You just need to remember these facts, guys. The reason I give you quizzes every week, because you keep revising the notes, so that you remember things, Okay? Alright, guys. Yes?
A equals n was I did it a different way. So I substituted that in.
Oh. How did you get this 1 over n? I thought it's k. There's no. I thought the question was, sorry, what was the question? The question was k times this.
Yeah.
So where you get this 1 over n from? It shouldn't be here.
Yeah.
It should be k times this, right? So you should, the 1 over n shouldn't be here.
Yeah.
Okay. Are you guys okay with this or not? Yes. Can you follow? And we do the next one, please. Question 7. Question 7, please. the sign? Oh yeah. Oh, sorry. Your friend over there. No, thank you. Thank you. Right, question 7 also involves the Pascal distribution. So think about it, think about it. Think about using the Pascal one more time. Question 7. Why not? Let's do it. Right. So we want the probability that now S squared is the sample variance. Now what's the formula for the sample variance? I'm sure I gave it to you. What's the formula for the sample variance? Huh? It's 1 over n minus 1, which is 1 over 9, right, times the sum from 1 to 10 of xi. Do you remember this? This is the formula for the sample. 1 over n minus 1 times the sum of xr minus x bar squared. Right? Yes? Now the next thing I'm going to do is I'm going to multiply all the numbers here by 9. So it's going to be it's 9 times 60. Right, the next thing is I'm going to divide all the numbers by sigma squared. Sigma squared is 36. You will see why I'm doing this in a minute, but right. Okay, let me ask you something. Don't disappoint me this time. Okay, what distribution does this have and why? Do you recall this? I talked about this in the class. You don't recall? Come on, guys. You don't recall this, guys? Do you recall this result I gave you in the class? Yes? Alright? So that's what I'm going to use. If I use this, you get what you get. Okay, and this you'll need a computer to work this out. So for example, in R, if you're using R, you can compute this as follows. Alright, DF stands for degrees of freedom. Alright, so that's part 1. Do you follow what I've done here or no? Yes or no? So this is a result I gave you a while ago in the class, in the lectures. Do you recall this or not? Yeah? It's important that you do revise your notes, guys. So this, I've used this one, right? Now part 2. So this is part 1. Part 2 of question 7. Shh, listen guys, please. So part 2 is to find n, so the probability that s squared is greater than 20 is equal to 0.9. Okay, so which is the same as saying yeah, which is the same as saying that yeah, and next thing I'm going to divide by sigma squared on both sides. So sigma squared we know is 36. Right? Now by the same result that I just mentioned, right, what you have is the probability that a chi-squared variable with n minus 1 is greater than right? And the question is to find n. So obviously you need to solve this equation for n. Alright, obviously you cannot solve it by hand, right? You have to use a computer program to solve this equation for n. N is the sample size. So it can be done, for example, using R. Okay. Alright guys. So that's question 7. Now can you do question 4 please? You can skip 5 and 6. Can you do question 4 please?
Sorry, excuse me. Why can't you just do it from that?
Yeah, yeah. Is that right? 5, 5. Sorry, 5 over 9. Sorry, thank you. It should be 5 over 9, yeah. Oh man. Not, it should be 5 guys, not 4. 5 over 9, yeah. Yeah, I don't know how to. Yes.
Why can't you use chi-square distributions here?
Chi-square?
Yeah. Why can't you use it? Why do you have to divide the times so clear like that?
That's the result, sir. That's the result I just gave you on the top. You see, there's a result in the red box which says that 1 over sigma squared times that has a chi-square distribution.
Yeah, but why can't you say that's the chi-square distribution? Because
1 over 9.
yeah, you said the 9 is sigma squared.
No, 9 sigma squared is 36, sir.
How does it say?
It says here, where does it say? Number 7, yeah. Sigma squared is 36. Yeah, sigma squared is 36. It has to be 36. Yeah. Can you do question 4 please now? Question 4. Can you get 4 days or what? Yeah. Right. you have one random sample of size 10 from a normal distribution and another random sample of size 15 from the same. Now let x bar 1 denotes the sample mean for this. What distribution will this have? Again, checking your memory, guys. What distribution you think it will have? If x bar 1 denotes the sample mean of the first sample, it will have normal with what? Do you remember? I've forgotten. Let me write this down. Just checking. This will test your memory. Do you remember this or no? Get another box. Do you remember this? I gave you this long time ago. Okay, so this will be 20. And this guy here, if x bar 2 denotes the sample mean for the second sample, it will be 20, 3 over 15. The question is to find the probability that the absolute difference between the two is greater than 0.3, right? Which we can write as the probability that O right. Now what you have here in both places is a difference of two independent normal variables, which again, by one of the properties I mentioned in the class, when you have two independent normals, the difference also normal, right? So that will be normal with mean 0 and variance this, right? Okay, and plus I'm done in a minute, guys. Just be patient, guys. Less than minus 0.3. all right. Now I will stop here because I'm sure you know where to go from this, right? Do you know how to work this out? You just standardize this to standard normal by subtracting the mean and the square root of the variance, and the same thing here, and then read the table. Right? If you're not sure, you can look up the solutions online. The solutions for all the problems are online in the course website. Yeah? Okay? Alright guys, if you've done quiz 6, can you give it to me now, please? Or you can give it to me tomorrow. Yeah, see you, man. Hello. Good, thank you. Thank you. Hi, thank you. Hi, thank you. Now you done? Oh, thank you. Have a good weekend, man. See you, man. Hello. Thank you. Thank you, man. See you.